Bismillahirrahmanirrahim. Assalamu alaikum. This is Taiba Arif along with my group member Reha Aftab from Chemistry Department from Fatma Jinnah Women University, and we are going to discuss the application of titration in inorganic analysis. So inorganic analysis basically involves a variety of analytical methods which can be qualitatively or quantitatively determine the inorganic and elemental compositions of solid, liquids, aqueous solutions, chemical mixtures, materials or products. So inorganic components include cations, metal or anions or inorganic salt. Moving to the first application, that is the application of optical fibers in oxidation reduction titration. So oxidation reduction titration is also called redox titration, and in this type of titration the indicator action is analogous to other type of visual color titration. So in the immediate vicinity of endpoint, the indicator undergoes oxidation or reduction depending upon whether the titrant is an oxidizing agent or a reducing agent. So the oxidized and reduced form of the indicator have distinctly different colors. So optical fiber system used for the determination of endpoint in redox titration, and this method seems to be independent of both physical and chemical properties of reagent. So the practical applications we have been used in optrode, that is basically an optical sensor device that optically measures a specific substance, usually with the help of chemical transducer, and based on the use of colorimetric indicator, the indicator was N,N-diphenyl benzadiene. So a low-cost optoelectronic system that consists of bifurcated optical fiber bundle that basically consists of two fibers side by side in the common end and break out into two legs at the other end, with light emitting diode, a light source and a silicon photodiode photodetector. Now moving to application of bipotentiometric titration, also called redox titration. Bipotentiometric titration is used as oxidation reduction, acid-base precipitation and other combination titrations. Bipotentiometric titrations are also applicable for small samples. Precision and accuracy of bipotentiometry in redox titrometry and is used for polarized electrodes for the endpoint indication of titration. So natural monocrystalline pyrite as a sensor for potentiometric redox titrations, and that are basically titrations with permanganate, and potentiometric titrations of Fe2, Mn2 and As3 with the standard potassium permanganate solution, and in titration the endpoint was detected with a universal electrode whose sensor is natural crystalline pyrite, and the result obtained by using the pyrite electrode were compared with those obtained by application of platinum electrode, and the good agreement, reproducibility and accuracy was obtained. Now moving to the determination of water in non-aqueous solvents. So the titrant for the analysis is Carl-Fischer reagent that basically consists of a colorless solution of pyridine, sulfur dioxide, iodine and anhydrous methanol that reacts quantitatively with water to form a colorless solution and is used to determine the amount of water in numerous substances. Now moving to Carl-Fischer titration. So Carl-Fischer titration is basically the titration method that uses either a volumetric or colorimetric titration to determine the water quantity that is present in a given analyte. So this method, which is used for quantitative chemical analysis, was first developed in 1935 by a German chemist, Carl-Fischer. Now moving to its principle. So the principle of Carl-Fischer titration is completely based on oxidation reaction between sulfur dioxide and iodine, and water reacts with sulfur dioxide and iodine to form hydrogen iodide and sulfur trioxide, and the primary alcohol methanol that is used as a solvent, and a base pyridine is used as a buffering agent. Now here I am going to discuss the Carl-Fischer titration equipment. So basically it consists of a detection electrode, a small injection part, a pulse motor, a piston burette, and a detection unit and a data processing unit. Now moving to Carl-Fischer reactions. So Carl-Fischer titration experiment is performed in two different methods. So first is volumetric determination. So this technique is suitable to determine water content down to 1% of water, and the sample is dissolved in Kf methanol and the iodine is added to Kf reagent, and the endpoint is detected potentiometrically. The second one is colorimetric determination, and here the endpoint is detected electrochemically. So iodine required for KF reaction is obtained by anodic oxidation of iodide from the solution. So pyridine concentration is large, so I2 and SO2 are complexed with pyridine, and when added to sample contain water, I2 is reduced to I negative and SO2 is oxidized to SO3. So indication of the endpoint, the solution changes from the yellow color of the product to the brown color of the Coral Fisher reagent. So now moving to the uses of Coral Fisher titration in various fields. So widely used for direct analysis of water content in various industries as a reliable and robust method. Coral Fisher titration method is a useful method for the water determination in various materials, including less soluble or insoluble samples. The water content can be easily and selectively determined in complex food matrices such as dairy, meat products, honey, sugar, chips, chocolates, fruits, and vegetables. So there are many advantages for water determination by KFT that cover all the water content ranges and determining of both free and strongly retained water. Moving to the applications in cosmetic industries, so it is used for the determination of water in shampoos, creams, lipsticks, and toothpaste. So in pharmaceutical industries, it is used for the determination of water content in raw materials, active substances, lyophilized substrates, tablets, ointments, and oils, and also used for the determination of water in silk, wool, wood, paper, building materials such as zeolite and cement.
Assalamualaikum, I'm Miha Tabkiani and I'll start with the role of Carl Fisher titration, also known as KF titration in the agricultural field. In the agricultural field, the KF titration is basically used for the determination of the quality of fertilizers that are used. First of all, for the process of titration, we need certain reagents and operators. The operators include the KF titrator, the graduated cylinder, beaker, and a balance. The images of all the operators they are given. Then the reagents are the KF reagent that includes sulfur dioxide, iodine, along with the solvent that is pyridine, methanol, and the fertilizer that is to be analyzed. Now the procedure of this process includes that first of all we know that this KF titration is used because we determine the water content in the sample that is to be analyzed. तो हमारे पास अभी जो sample है that is the fertilizer. अब हमने सबसे पहले रिएक्शन को देखना है कि इस KF टाइट्रेशन का बेसिक रिएक्शन क्या है. तो जो फर्स्ट यहाँ पे पॉइंट है कि दिस रिएक्शन दैट इज वाटर अलॉन्ग विद सल्फर डाइऑक्साइड एंड आयोडीन द रिएक्ट एंड प्रोड्यूस सल्फ्यूरिक एसिड एंड हाइड्रोजन आयोडाइड. दिस इज द बेसिक रिएक्शन. अब हमने ये जो देखना है कि जो जैसे हाइड्रोजन आयोडाइड है वो कलरलेस होता है और ये जो आयोडीन है दैट इज डार्क रेड इन कलर. सो दिस चेंज इन कलर इज बेसिकली यूज्ड टू डिटरमिन द ओवरऑल वाटर कंटेंट दैट इज प्रेजेंट इन द फर्टिलाइजर्स. अभी कैसे होगा कि फ़र्स्ट ऑफ ऑल हम देखेंगे कि एक फर्टिलाइज़र जो हमारी सैंपल है वील प्लेस दैट फर्टिलाइज़र इन द बीकर कंटेनिंग द सॉल्वेंट हमारे पास मेथनॉल होगा. ठीक है. अब सॉल्वेंट हमारे पास मेथनॉल होगा लेकिन हम जो कार्ल फिशर रिएजेंट होता है इसमें हम पेरिडीन भी ऐड करते हैं. वो क्यों ऐड करते हैं? बिकॉज जो सल्फर डाइऑक्साइड और आयोडीन होते हैं दे आर इन द गैशियस फॉर्म. तो उनको ताकि वो इवेपोरेट ना करें दे आर सो दैट दे डू नॉट escape from the solution, तो हम उसमें एक सॉल्वेंट ऐड करते हैं दैट इज पेरिडीन. ठीक है. अब यहाँ पे ये होगा कि फर्टिलाइज़र हमने एक बीकर में प्लेस किया, उसमें सॉल्वेंट प्रेजेंट है मेथनॉल. अब हम उस टाइट्रेट करेंगे विद द कार्ल फिशर रिएजेंट इन दी KF टाइट्रेटर. अब जब हम उसे टाइट्रेट करेंगे रिएजेंट को तो उसमें ये होगा कि जो आयोडीन प्रेजेंट होगी रिएजेंट में, हमें मैंने ऑपरेटर्स रिएजेंट्स में बताया था कि इन द कार्ल फिशर रिएजेंट आयोडीन सल्फर डाइऑक्साइड वाटर एंड सॉल्वेंट इज आल्सो प्रेजेंट. So for this purpose, when we will titrate that Carl Fisher reagent in the beaker, so the iodine present will react with the water that is present in the fertilizer, और वो जो dark red color होगा iodine का after the reaction with water, it will turn into hydrogen iodide and it will become colorless. So this changes in color is basically used to determine the moisture content. क्यों होगा? अब जितना वो आयोडीन जो रिएक्ट करेगी वाटर के साथ, अब मैंने बता दिया वो एक कलरलेस सोल्यूशन में चेंज होता रहेगा, हाइड्रोजन आयोडाइड बन जाएगा. अब द वॉल्यूम ऑफ आयोडीन सोल्यूशन दैट इज रिक्वायर्ड टू टाइट्रेट द वाटर दैट इज प्रेजेंट इन द फर्टिलाइजर वी कैन डिटर्मिन एंड एस्टिमेट द मॉइस्चर कंटेंट. ठीक है, दिस इज द प्रोसीजर for the determining the quality of fertilizers in terms of moisture content. So now the next application of the KF titration is the role of this titration in the plastic industry. Before coming to the procedure, we'll discuss some important parameters that include the operators, the reagents, and the experimental setup. So the figure shows the experimental setup for the KF titrations required to determine the moisture content in the plastic or the polymers, depending upon the type. The operators includes the KF titrator, graduated cylinder, beaker, and the balance. Whereas when coming to the reagents, they include the KF reagent, as I have told earlier that the KF reagent includes sulfur dioxide, iodine, pyridine, and water. Now we know that polymers, they are hardly or not at all soluble in the common KF solvents. So in order to extract the water trapped within the sample, that is the plastic, it must be dissolved or swollen by an appropriate solvent, so that the water present in that plastic, it is released through diffusion. So this appropriate solvent basically depends upon the properties of the plastic. Some substances, they can be easily analyzed through different solvents depending upon the type, whereas most samples of plastic, they require the addition of solubilizers. Why solubilizers are now used? Because they avoid the precipitation of the sample in the KF solution. So basically now the reagents include the KF reagent, the solubilizers, the solvent, and then the plastic, that is the sample to be analyzed. So now comes the procedure. The first step is that dissolve plastic in an appropriate solvent, that is chloroform, and in a solubilizer, that is the trichloroethylene. I have told the function of solvent and the solubilizers. The next step is now, after dissolving plastic in solvent and solubilizer, now we have to use puree to titrate specific amount of KF reagent into the vessel that contains the sample. The procedure is now same as I have discussed previously in the agriculture field when we are determining the moisture content in the fertilizers, that now KF reagent contains iodine. Now this iodine, that it will further react with the water that is present in the plastic and form hydrogen iodide, that will be a colorless solutions. So now the KF reagent that is used to neutralize the water basically determines, or we can estimate, that water content that is present in the sample. The last application includes the role of Carl Fisher titrations in the petrochemical industries. First of all, we'll discuss the titration parameters that comprise of the reagents and the operators required for this titration. That includes the KF reagent, the solubilizers, the KF titrators, beaker, graduated cylinder, and also the sample size, it must be 5 milliliter. The procedure includes that we have to determine the water content in the petroleum products. We all know that petroleum products, they are mixtures of long chain or aromatic hydrocarbons, and these hydrocarbons, they are hardly soluble. So the saturated hydrocarbons, they are mostly titrated easily, but there are solubility problems, and in order to overcome these solubility problems because of the presence of the non-polar or the weakly polar substances, the addition of the solubilizers to the solvent is very much necessary. Now I have told earlier that solubilizers are basically used in order to prevent the precipitation of the sample, whereas a solvent is also necessary because it is used to dissolve the plastic or the petroleum, whatever the sample is, in the properly, and so that we can easily extract the water content. So for the saturated hydrocarbons, and for the unsaturated hydrocarbons, that are the petroleum products, mainly long chain alcohols, they are used as the solubilizer, that include decanol, propyl alcohol, toluene, chloroform is also sometimes used, and xylene is also used. It depends upon the type of the petroleum product, whether it is saturated or unsaturated or aromatic, depending upon their properties. So now the first step is that we have to dissolve the first we have to dissolve the petroleum in an appropriate solubilizer. So here we are using decanol. After dissolving to a solubilizer to the solvent, now we can see that the water content is extracted. Then we have to titrate the KF reagent into the vessel that contains the sample and stir for almost 1 minute. Then after stirring for 1 or 2 minutes, we'll see that there will be a change in the color of the solution because of the addition of the KF reagent. That the iodine when present in the reagent will react with the water that is present in the sample, and and will form hydrogen iodide. This hydrogen iodide results in a colorless solution, and we from this the KF reagent that is used to neutralize the water in the sample, we can determine the water content. Now proceeding further in the inorganic analysis, now we'll discuss the role of the acid-base titration in the biodiesel fuel. Before talking about the role of acid-base titration in the biodiesel fuel, first we'll see the general introduction about biodiesel fuel, that it is a renewable form of energy that is taken from the natural oils in the vegetables, and this biodiesel fuel is now used in diesel engines as a burning alternative to petroleum-based diesel. And biodiesel fuel is created from the vegetable oil through a chemical process called trans-esterification, which will be discussed further. In this slide, we'll discuss the process of trans-esterification. Here, it is shown that a triglyceride, that is a fat, when reacts with methanol in the presence of sodium hydroxide, that is a strong base, it splits into or separates into two products that are the mixtures of fatty esters and glycerine. Glycerine, also known as glycerol. And the blue arrows or the blue box, they basically indicate the formation of the fatty esters, whereas the dots that are in pink in color, they indicate the formation of glycerine. Here the trans-esterification reaction basically produces two products. First is the fatty esters and the second is the glycerine. The glycerine is basically used as a byproduct to make soap and the skincare products, whereas these mixtures of fatty esters are basically the biodiesel fuel. This trans-esterification process uses a strong base such as sodium hydroxide in order to convert this vegetable oil into a combustible liquid, and it is very much important to measure the correct pH of the biodiesel, so that a known amount of base should be used for the correct pH of the resulting solution. Now we'll discuss that what is the role of acid-base titration in this formation of the biodiesel fuel. First, that the acid-base titration basically it works to neutralize the fatty acids that are present in the vegetable oils. And then after in order to neutralize these fatty acids, a known amount of base is needed to neutralize them in the oil. Next, then the dilution formula, that is M1V1 is equals to M2V2, is used in order to calculate the right volume of the base required to make the biodiesel fuel. In this formula, the V2 will be the volume of the base that we have to calculate, whereas the concentration of the acid and the base will be known, and the volume of the acid present in the oil will also be known. Then indicator will be used that will tell us that how much base is needed to neutralize the fatty acid by changing the color, and endpoint will be the change in color of the solution. Thank you so much. This was all from our side.